Hello everybody. Buenos días, bon dia. Comencem una conferència organitzada pel grup Traducmàtica. We're going to start a conference organized by the research group Traducmàtica on MT quality. We are very happy to have with us Andrea Tabacchi from MemSource. He's a solutions architect at MemSource. You may probably explain to our students what this means. And he will be talking to us today about estimating machine translation quality. We will be happy to hear all your questions on the topic at the very end of the conference. And through Twitter, we've got hashtag TraducmaticaMTQuality. Where you can follow the conference and ask your questions as well, and we'll be bringing them to the room at the end of the presentation. Thank you very much, Andrea.
Thank you. So good morning everyone. So what I will be talking about today is the project that we embarked. Actually, it was 1 year and a half. Was the one of estimating machine translation quality in an automated way. So why did we embark on this project, and what are we trying to solve from the business perspective? So whatever I will be talking about today, everything I will be talking about today, is everything from the business perspective. So what are we trying to solve for our customers and our users? So I will start by introducing who we are, who we are, and as MemSource, and who am I, and our view on machine translation, the MemSource artificial intelligence journey, because MTQ is part of the artificial intelligence project that we are running within the company. I will be talking about machine translation quality estimation, so MTQE. I will be talking about the first pilot that we ran back in August, between August and October, and which results were presented at Take-Home Conference in Germany. I will be talking about version 2 that has just been launched. I think it was a month and a half ago, and the conclusions that we are getting out of this up to now. And then of course, I will have you're more than welcome to ask questions. The presentation is going to be around 30 minutes, so we will have plenty of time for questions. And so let's start. Who we are. My name is Andrea. I'm the lead solution architect at MemSource. The solution architect in a software company like MemSource is the person that is working in strict contact with the customer and with product. So what we are trying to do as solution architect is collect the needs of our customers, our customer and prospects, and then transform them into features that then are implemented in the tool. I started as a translator myself. I studied translation at the university. It was back some time ago, and then I started, since I didn't like translate too much, I have to admit. I started to play around with technology, and I started to work as a localization engineer for a Chinese LSP, and I moved in different positions within the company. Then I moved back to Europe. I work on the LSP side for approximately 10 years here in Europe, and then I joined MemSource because I wanted to move, to make a career move, I was looking for, or join the customer side as localization manager, or move into the technology side. I've been working with machine translation for the last 10 years. I've been playing around with statistical MT. I've been playing around with a little bit with rule-based MT. I did some experiments. I tried to implement it multiple times in the workflows, and I succeeded with some SMT, and I also played around with NMT when it started. So who we are in terms of MemSource, I don't know, I guess more or less it is a known company. We are a translation management system. We started as a CAD tool, and then we move into developing more and more features regarding project management. Right now, MemSource is a solution that is used by translation buyers, so enterprises like Uber, WhatsApp, and other companies in the Silicon Valley, then language service providers and translators. So what we are trying to develop is a tool that can be used by all the different stakeholders in the localization process. Couple of figures. In 2016, we reached the record of uploaded words in MemCert. It was 16 billion. Right now, we are 40 billion words uploaded in the tool in the year. We are around 100 people, of which like 45 people are developers, and we launched the first AI-powered feature last year. The first AI-powered feature was the non-translatable, the second was machine translation quality estimation, and we will be launching more this year. Our view on machine translation is, I mean, it's, instead of talking about like the usual, okay, first it was statistical, then rule-based, and then hybrid, and then neural, and then like instead of talking about the technology, I would like to take it from the user perspective. So what I personally saw in the implementation of MT was that 10 years ago, the technology was not mature enough, like to be implemented. But it was not only the technology that was not mature enough, it was the quality of the source content was still not there. Like, I mean, some companies were working with simplified technical English, so you could have some quality in the source content, but it was definitely not easy. It was not easy to be translated by a human, imagine from a machine. There were not enough data to actually train domain-specific engines, or there were enough data, but then, I mean, it was only on certain domains and not in others. And of course, there was the posterity availability. So people didn't know how to do posterity. 5 years ago, I personally succeeded in implementing in multiple scenarios machine translation. So, but I still saw that in the industry there was still some resistance. The resistance was simply because change is hard. I mean, and when you have to change from a given process in which you're used to work, like it's very difficult to change. So and procrastination is human. I mean, you always postpone. I'm going to do it tomorrow. I'll do it tomorrow. I'll do it tomorrow. And right now, we are in the situation in which it works. Machine translation works. Like, there are multiple technologies out there that are having outstanding results. I mean, I'm talking about, okay, Google is incredible in many different scenarios. DeepL is having incredible results. We know the research at Microsoft, like, is also very advanced. We are in strict contact with Amazon. Amazon is also doing quite some interesting things. And of course, like, you have all the community around OpenNMT, like that is like Stanford University. Then you have Systran, that in the end they are helping developing a working open source solution. So what did we see as the main obstacle in machine translation implementation? So the first that we saw was the results unpredictability. So I'm pushing some content into a machine translation engine, and I'm not always sure of the output that I'm getting. This might depend from, especially when working with generic engines. I'm not talking about when you're working with, the more you're working with domain-specific engine and the more you're working with standardized content, the more predictable it is. But then if you're working with generic content and generic engines, the results are unpredictable. Sometimes they're good, sometimes they're bad. And this is, of course, one of the obstacles in machine translation implementation. I'm talking about implementation in a localization process. So where I have, like, the source content is pushed into a localization process. It is machine translated. Then you can decide if you want to push it already online or if you want to have somebody posterity. There was a complexity of use, like for certain technologies. Like it is clear, like certain technologies are plug and play. Some others are more difficult to use. There are many technologies, especially now, available on the market. So it is very difficult to choose, especially if you don't really know, like, what are the technologies out there, what are the benefits, or like you don't really know which one to use. Like if I have to pick, for example, between Google and Microsoft, which will I pick? I know that sometimes Google will perform better, but I am not sure. And then, like, there is an undefined effort estimation. How can I identify the effort that is required for posterity? This is a very tricky thing, and there is no standard. For translation memory, there is a standard in the industry. That is like the cut bands. Like, so you got 100%, you got 75%, 95%, whatever. And there is a pricing model attached to that. For machine translation posterity, there is no. there are some models that are related to the historical results of the MT engine, but then given the fact that the results are unpredictable, like you can have some historical results, but then these results will not be useful for the implementation. So how did we try to solve these obstacles, or these problems that we saw in the industry? So first of all, as MEMSers, we decided to connect as many technologies as possible. At this point, I think you have around 25 machine translation engines available in MEMSers. You can plug even more. But I mean, we are plugging even more, and we are always on the lookout on what are the new technologies that are coming out. We try to find a way to develop something to estimate the effort, therefore MTQE, but also to verify it afterwards. So built-in MEMSers, you have some edit distance report. If you are brave enough, you can also play around with time tracking, because we don't explicitly show it within the UI, but if you want to track the time, it is possible, within using some advanced reporting. We want to simplify the selection of the MT engine using machine translation quality estimation. So an automated quality estimation we want to simplify, and this is the feature that I'm going to talk about towards the end that is called MEMSers Translate. And we want to allow the customization directly from MEMSers. So I have Google AutoML, or Microsoft Custom Translator, or whatever technology, or system, whatever technology that I can customize. I want to be able to push the content from MEMSers directly to the engine for customization. So this is currently under investigation, because of course, we need to understand what are the point of contact between the two technologies and how we can streamline the process of pushing the content there. So. A quick introduction into artificial intelligence at MEMSers, because I mean everything that MTQE and MTQE specifically is born from an effort done by the AI team. So in 2016 there was the hype. I mean there is still the hype, even more right now. But in 2016 we started to read about artificial intelligence. So what is this? We went to conferences, we studied, we dedicated. One of the most senior developers started to investigate. Can we do something out of it? Can we really build something? And we decided to build a team. The team is composed by data scientists, developers, and NLP professionals, so people that are coming from academic background in natural language processing, and data scientists. So we put together a team of, and of course, we had to develop an infrastructure dedicated to that, because as you can imagine, the computing power that is required for these type of features is much more than actually what it was used up to that moment for our tool. One thing, MEMSers is only cloud, so it is not on server, it's not on premise, it's only cloud solution, and that is why also we can do all those kind of things. In 2018, we released non-translatables and machine translation quality estimation. So why non-translatable are AI, are categorized as AI effort? Because the previous non-translatables in any other tool are rule-based. So you say an email that is always composed by a certain amount of letters or numbers, or followed by a net, and followed by a domain. It is always not to be translated, and you can tweak it, and you can write regular expression. Regular expression are patterns that will be able to recognize. Of course, regular expression are not perfect, because in certain cases an email is not a specific case, but in a city, in certain languages you will translate it, because it has to be translated. Imagine London in Italian, French, in Spanish, in Chinese, in all the languages it is translated. So if you were looking for places, in this case, this will not be a non-translatables. If your regular expression were looking for places. So we build a model that is based on neural networks and on the historical data, and this model is able to identify what is not to be translated with a confidence score. And having started investigating this confidence score, we decided to start to work also on machine translation confidence score to understand if we can apply a confidence score even to neural MT. And last year we finally realized what was the mission that we wanted to follow the vision that we wanted to follow as a team, as artificial intelligence team. Like, it's the one of building an intelligent translation management system. So we are going beyond what is machine translation. We will go beyond what is non-translatables. We will start to work on what is possible to automate within the tool, what is possible to automate within the process, to simulate, to make the tool more intelligent and able to react to situation, and not only you as localization manager setting up everything and then the system is unable to react to changes. The system will be able to react to changes as well. What we will be developing in 2019 or releasing in 2019, it can be shared right now, but is very, very interesting. So then let's talk about MTQ, because we are all here to talk about, to listen to what's machine translation quality estimation. So what is it? It applies a confidence score. So a quick question for the room. Like, I don't know, did you use MemSource in the past, and did you use MTQE? Have you tried MTQE? Like it is okay. It applies a confidence score at the segment level. I will show you the screenshot later on. It is based on appropriate modification of CHRF3. That is one of the quality index that can be used. It is appropriate modification that is simply because we wanted to improve it, because in certain cases, like we identified the CHRF3 was the reference, like as an index, but then we wanted to improve it. It utilizes deep neural network. It is trained on historical data, and currently it supports 71 language pairs. So it is language related. So in certain situations, in certain situations you won't be able to use it, but it covers already quite some language combination. It is machine translation language independent, a machine translation engine independent. So it means that MemSource will act as a separate thing, as a referee, saying, okay, not as a referee, but as a judge, saying, okay, this machine translation output is good, this machine translation coming from Microsoft is good, and this one from Google is not good. The goals that we had as a business, like, was to improve, like, provide better project scoping. Like, so when I'm analyzing the content, I will be able to know if machine translation is gonna provide me an improvement in the project. Like, so I will know upfront if it makes sense to apply machine translation or not, and I can decide to unplug machine translation, because if it doesn't make sense, it's useless to apply. And we noticed down the line that it actually improves also posterity, and I'm going to show you a few data later on. The graph on the side is just like an oversimplification. Even if it's true, it's coming from data, is an oversimplification and it says, like, okay, like the better it is, the machine translation output, you can see the faster is the translator, and the straight line is the average translation speed. Of course, average translation speed depends from the translator, depends from the content, it depends from so many things, and the same goes for the machine translation quality output. So it looks scientific, but in the end, like, it's not really scientific. Like, we can, if you want, we can work on specific projects together. So this is how it looks like in the UI of MemSource. So what you will be having on the side is a score. I'm going to go into the scoring later on with 3 dots below. So the main difference between the translation memory and the machine translation is represented by the fact that you have 3 dots below. The fact we decided not to add other stuff in the UI simply because it was already crowded. So if we were starting to add another thing on the side that this is a good machine translation or something else, it was going to be crowded. And so for the UX point of view, it was not going to be usable by the translator working on the project. So, like, for you as a post-editor, or if you will be working on post-editing projects, like, pay attention when you have the 3 dots, means that this is a score that is automatically generated. The pilot that we run was run with Semantics. That is one of the biggest language service. It is actually the biggest language service provider in the Nordics. So Sweden, Norway, Scandinavia, and Finland. And it was presented at TECOM in Germany back in November. What we were looking at is the predictive accuracy. So how accurate was the prediction of the MTQE, and if there were productivity gains for the linguists working on the project. How we did it, like we compare thinking time and editing time in a randomized trial. So we actually collected like quite some words in which we were using machine translation. We were not using machine translation, we were using machine translation, and we were using machine translation with quality estimation. So there were the three things. In order to compare, okay, with no machine translation, what is the average time that it takes? With machine translation, what is the average time that it takes? And with machine translation plus machine translation quality estimation, what is the average time that it takes? And we then, of course, like given the fact that we are both like we are in for the business, like we also calculated the weighted word count reduction that was generated by the usage of MT and machine translation quality estimation. So the results that we saw, like, and imagine that like this was version 1. So version 1 was, of course, like was not perfect, and we'll show you also what we introduced with version 2 as a further improvement. There is no discernible difference between thinking time, when working with machine translation or machine translation and quality estimation. But there is somehow a reduction in the editing time, a 3% reduction in the editing time when you apply a score to a given segment. So if I am a post-editor and I don't have any score, I'm actually slower in editing the content than being a post-editor in which I have a segment with a score applied. Especially like we then look into like a specific subset of content. There was technical documentation. Then, of course, technical documentation is better. If you want to apply machine translation, you are going to get better results. We look specifically at the time spent and predictive accuracy, and this is the result that we got. Like as you can see, like this is in gray, like is the editing time, and the thinking time is in yellow. As you can see, the editing time was drastically reduced by the fact that I had a score applied. At the time, we were 100%, 95%, and 85% as 3 different scores. There is a strange result if you look at it, like between 100%, 95, and 85, because actually I'm faster at the 85% and I'm slower at 95%. What was our take on that? Like, was the 95% means that is kind of almost perfect, but is not perfect. So as a person that I'm doing the editing, I will pay extra care about it. Like I will pay extra attention about it when I'm doing the post-editing. While if I'm 85, I know that like a part of it is already wrong. Like so, I'm sure it's wrong. So it might take me less time. So I have to pay more attention when it is a high fuzzy than actually when it's a low fuzzy. And I guess this is also working when working with translation memory. So machine translation quality estimation version 2. Version 2 was released 2 months ago, and we actually redefined the scoring and the overall scope, the focus of the feature. We are referring to, while version 1 was concept focusing on perfect and near perfect outputs, version 2 will go into a whole range of machine translation quality. So we actually want to try to intercept also what is a potential fuzzy, because what we notice is that like in MTQ version 1, it was we were actually able to identify only 10% of the segments. Let's suppose that I have like 100 segments with no translation memory attached. I will be able to identify only 10%. With MTQ version 2, we wanted to enlarge the number of segments we were able to identify. Of course, like when you having this point, like trying to have more segments, what is going to bring that is going to, you might be wrong more often, because of course, like before, like you were very sure of what you were doing. Like right now, we might be wrong more often. But I mean, the results are coming in and are positive. The categories in version 2 are 100%, that is perfect machine translation. This means that is machine translation that does not require any editing. 99, that is near perfect machine translation, so it will require some minor editing. And 75, high quality, but you might want to do post-editing. I guess like one of the questions that is going to come before like is how we come up with these predictions, because I guess like you would like to know. Yeah, okay. Do you want to know it now? Should I do already answer? Like, okay. So yeah, we have source, machine translation, and then the score that was generated in the past. Like, so I have a source content, I have machine translation content, and I have like what we used for the model training was the score that is categorized with good MT, almost good MT, and not so good, high quality MT, and then bad MT. With these three data, we trained our model, and in supervised learning. So it is supervised learning, it's given saying, okay, every time, and like, sorry. So it's just because like every time I'm trying to explain it, it's kind of complicated for me because I'm not the guy who's actually doing the job. Like, so is the source, the machine translation, and the score will be used and transformed in numerical transpositions. Then every time a source content comes in, it will be compared with the formula that is generated in the neural network, and a score will be generated. So if there is similarities with the new content, with the content that is present in the model, then we will be able to generate a score and say this is good MT or this is not so good MT. This is how it works in a very bad explanation. But if you want, I will send you a better explanation. Like I will send it to Pilar and then. So language coverage. For now, like this is, as I said, like the language coverage is around 70 languages right now. This is the language coverage that and these are the results that we got on the sample data that we use for our training to understand like what is and it is a randomized number of words, like, and we are talking like about like 500 million words, and every time before, like, to verify that like the training of the model was good, we run this test. Like, so we saw that certain languages are performing better than others, so we will know that, like, we know that in English into Spanish will do well, English into Portuguese will do well, but English into Japanese or English into Chinese, we won't be doing that well as the others, because the languages are more difficult. This is using Microsoft as a machine translation engine. So, I mean, the results, I mean, this is just for us as a benchmark to know if we are going in the right direction. Like when working in, you can use other machine translation engine, you will get other results. This is only to give an idea. The preliminary feedback that we got, like from the people who are piloting MTQ version 2, is that from the business perspective, it makes sense because I can understand, I can assess the quality of machine translation up front. It reduces post-editing time. We don't have the exact figures, but it reduces post-editing time. We were able to apply a score to 35% of the segments. I'm going to show you like the breakdown of the content right after. And we noticed that when it comes to fuzzy, quality is still a subjective matter. So whatever is a 75 for us can be 100% for somebody, or it can be 0% for somebody else. So sometimes it's good, sometimes it's not good. So it is still hard to solve. But then this is the same also for a fuzzy that is coming from a translation memory, because in the end, like a super precise translator will throw everything. Like a translator that knows like that, okay, like quality is, the customer is not required super high quality, will just do some minor editing to make it understandable, and then it will send it. And of course, it very much depends from the engine and the languages. I mean, this is a no-brainer statement, but I mean, we don't have the same results on different languages. So this is the breakdown. I don't know if you can see it. No, you don't see it. So this is machine translation. This is the machine translation that we were able to identify. These are the high-quality machine translation. These are the matches that are coming from translation memory, and these are the no matches. So in terms of no matches, we are talking about, so on the randomized trial that our customers are, on the test that our customers are doing, 40% of the content is still no match, but then around 40% is content, around 35% is content that we were able to identify. So we were actually able to reduce, to identify part of the content and potentially reduce the posterity in time for the content to be translated. And it's already something, because before you didn't have this kind of information as a posterator, as a buyer, as a localization manager. So the pilot is currently ongoing, and the results will be presented in Brussels at LT Innovate in June. I don't know if you will come, but you're more than welcome to come to see the results. And but we believe that also from the feedback that we got from our customer, we believe that we are solving actually one of the major problems in the industry, like when it comes to machine translation implementation. Conclusions that we can take away, like it is, post-editing efficiency. It is, we are still discussing internally if we want to keep a generic model even for domain-specific engines. We are discussing that to give the possibility to have a baseline quality estimation model that the user will be able to train on specific data. And the interesting further application that we have are the dynamic ranking based on domain. So what we are doing is actually right now, there is a feature in MemSource that is called MemSource Translate that at this point in time works only with Google and Microsoft generic, and we rank according to the type of content. We rank the quality, and it will use the machine translation coming from Microsoft or to Google or from Google in using MTQA. Yeah. That's pretty much all what I wanted to share, and thank you.
Thank you very much, Andrea, for your oops. No? It's not working. No? No? Thank you very much for sharing with us all your results, which are very valuable for both for the business, for the industry, but as well for students that are right now trying to start their own career in this field, in the field
Yes.
of translation, and are trying to figure out where they will be doing in the next
Posterity.
in the next years. Are there any questions in the room? Please.
Will you launch desktop version ever, or?
No. Sorry. We have the desktop editor of MemSource, so you can use it in that. But for MemSource is only cloud, and will always be. I don't know, but I'm pretty sure.
Please.
So I guess you are referring to generic versus domain-specific. So if the quality estimation model will be generic or domain-specific, or you're more in, okay. So machine translation technology, right now you have the baseline technologies, commercial technologies like Google, Microsoft, whatever, that they offer you a solution that works for everything. They say at least that works for everything. DeepL, like whatever thing you throw at DeepL, the quality of the translation will be perfect. As the results of many studies on both academia and business shown, training of engines actually will get you closer to human parity. So in terms of machine translation results, in terms of output of the machine translation. The best result is actually when you have a very solid baseline engine with generic data that you train with domain-specific engine. So if I'm translating medical, I want to use medical data to train machine translation engine. Given the fact that on our end we have a generic approach, and what we will be receiving from, let's suppose that you will be testing this medical text with, on one end, you will have the medical engine, super trained with medical text, and on the other end, you will have the Google engine that is trained with generic data. You will get two results. At this point, given the fact that the technology is new, and it has been done, of course, in the past, like in different flavors, also with statistic, like, and it was different in the past, but we don't know if we will be able to score better, if we will be scoring better, like the domain-specific one or the generic one. So we have to pick, like we have to decide which way to go, but we will be able to do this only when we have some enough data, historical data, to then make an informed decision. Because right now, like even developing the possibility to train a domain-specific MTQE model will take some time. So on our end, we are still deciding which way to go.
Okay, thank you.
Does it answer? Like, it was a very long reply.
Yeah, I think I got the most.
Okay.
Thank you.
If not, I will ask. In your interface, like when you show the post editor, the quality estimation, when it's 100% and then maybe when it's 75%, do you see a bias from the post editors to confirm the segments more when the quality estimation is 100 as compared to when it's 75? And like in relation to that, if you see that like post editors or translators are confirming the 75% matches, like machine translation matches more, can you make a future estimation that your estimation is wrong, or is it evolving? Like the general question is whether this model is evolving or it's static. It will always give the same results with the same data.
It is evolving. It is evolving. It is not evolving as the projects are coming in. So let's suppose that I'm doing post editing of 1 million words, and these million words will not be used tomorrow to retrain the model, because to retrain the model takes a lot of time and money and resources, and so we are periodically gathering the data, understanding what we did right and what we did wrong, and then we retrain the model, and hoping that is going to be okay the next time. Because you know, as you might know, like when you retrain the model, then you might completely ruin it. Like, so it is also very difficult for that. So going back to the bias, yes, there is a bias. Yes, of course there is. But as there is a bias in the translation memory, I mean, there is like, I mean, I don't see any major difference in terms of the psychological approach to the thing. And so, but we notice at the same time that the 75%, like it depends on with who you will be working as post editors. Who will like certain people will, for 75%, will actually do some over editing. Certain others will do less editing. But it's very right now, like it would be maybe I don't know when we are gonna have enough data to show like what is the bias. But definitely we are gonna gather it and understand, because the bias is also on our end is the accuracy of the thing. Because in the end, like that's it is what it is. We suppose that who's post-editing will do their job.
Thank you. I guess that some of the results that you have been showing, that you have shown us, somehow we can infer that translators with more information about the quality of the segment feel more confident and might be more efficient when they post it. So I guess the next step would probably be showing which parts of the segment are high quality proposals, while which parts might be less quality,
Yes.
might have less quality. I mean, when we are translating from a translation memory is able to show us
Yes.
which segment, which element under the segment level is changing and is not being translated accurately enough.
Yes.
So do you think your system may evolve to that point? Somehow
that's
showing...
that's a very nice suggestion of Richard. Like this is definitely what we should be able to provide. I mean, as we are able to generate a score, we have that. It's just a matter of visualizing it in the user interface. So I'm not saying that it's going to come tomorrow, because of course, but it's definitely an interesting suggestion, and I will bring it to product. Because I mean, if we can make the life of the post editor faster by showing, okay, this part is good, the rest you can throw it.
Or you should focus on this part, because it's at the very end you're translating a whole sentence, so
Yeah.
you will have to manage with all the words in the sentence. But if you bring the attention of the translator to the point where the segment might be wrong, I don't know, it might give them more confidence
Yeah.
on the rest of on the other part of the segment.
Yeah. Thank you.
Thank you indeed. Okay. I don't know if there are any other suggestions or questions, or I'm
Okay.
sure that your results are being very, very inspiring, and I hope to hear from you very soon and from your quality estimation module very, very soon, and with new results. To all of you in the room, our research group, Traducció, is working with, collaborates with MemSource already for a long time. So if you need to test, or if you would like to test the tool, we will be happy to give you access to the tool. There's no problem with that. And for people, I'm not sure if we succeed with the streaming, because I think there were people at the very beginning, and then
Okay.
and then they moved. But I will also like to point out that this conference will be available through the UAB repository, and also for some of the students of our virtual courses that are following the course from abroad. Thank you very much, Andrea. It's been a pleasure
Thank you.
for us. Oh, there is a question, sorry.
Okay.
Sorry for interrupting. Pilar. There's a question from Clara Ginovartsit, and she's asking, is there any initiative to develop a plugin of MTQE by MemSource that would work with other CAD tools? Is there a beta
No.
program?
No.
No, it will be proprietary.
Yes.
Okay.
That's from the business perspective, this is a key differentiator towards other tools. So we would like the people to use our tool.
Okay. Thanks. I hope the person got his answer.
Again, thank you very much. We give this session closed. Thank you for your attendance.
Thank you.
And for the virtual followers, thank you very much as well.
Thank you.